In a previous lesson, we learned how to graph lines such as the ones shown here. Notice that these equations include both an x variable and a y variable. In this lesson, we will examine the lines that correspond to equations that have only one variable. So we will examine equations in the form x equals k and equations in the form y equals k, where k is some constant. Let's begin with equations in the form x equals k by examining the line that corresponds to the equation x equals 3. So first we'll find some points that satisfy this equation. Now the equation tells us that x must equal 3. So there's really only one way to satisfy this equation. X must equal 3. But what about the y value? Well, since the equation does not place any restriction on the value of y can be any value. So for example, y could equal 3. We now have one solution to our equation, x equals 3 and y equals 1. Another solution is x equals 3 and y equals 5. And here are two more solutions. From here, we can convert these solutions into individual points so we can add them to the xy coordinate plane. When we connect these points, we get a line, and this line is the graph of the equation x equals 3. So the graph of x equals 3 is a vertical line such that all points on the line have 3 as their x coordinate. Okay, now let's examine equations in the form y equals k. We'll do this by graphing the equation y equals -4. So what are some possible solutions here? Well, the equation tells us that y must equal -4, but places no restriction on the value of x. So one solution could be x equals 3 and y equals -4. Another solution is x equals 0 and y equals -4. And here are two more solutions. From here, we will convert the solutions to individual points so we can add them to our xy plane. When we connect these points, we get a line, and this line is the graph of the equation y equals -4. So the graph of the equation y equals -4 is a horizontal line such that all points on the line have -4 as their y coordinate. Okay, now let's summarize these results. The graph of the line x equals k will be a vertical line where all of the points have x coordinates equal to k. And the graph of the line y equals k will be a horizontal line where all of the points have y coordinates equal to k. In this lesson, we will examine slopes of lines. To begin, we can define slope as the measurement of a line's steepness. Our goal is to assign a number that describes the slope of a line, such as this one. To do this, we will say that the slope of a line is equal to the ratio of its rise to its run. Now, rise is the vertical distance the line travels as we move from one point to another, and run is the horizontal distance the line travels. So in this example, let's travel from the point 0, -1 to the point 3, 1. To do this, we must rise 2 units vertically in the positive direction, and then we must run 3 units horizontally in the positive direction. Now let's continue to the point 6, 3. To get there, we rise another 2 units, and we run another 3 units. So the slope of this line is equal to 2 over 3, since the rise here is 2 and the run is 3. Okay, let's look at another example. Once again, we will apply the formula slope equals rise over run, and once again we will choose some points on the line. So let's travel from the point 1, 4 to the point 5, 3. To do this, we first rise 1 unit vertically in the negative direction. So if we travel downwards, we are rising in the negative direction, and if we travel upwards, we are rising in the positive direction. Next, we must run 4 units horizontally in the positive direction. So here, when we travel from one point to another, our rise is -1 and our run is 4. This means the slope of the line will be -1 over 4, which is the same as -1/4. Now notice that the slope of this line is negative. So some lines will have a positive slope and others will have a negative slope. We will examine this shortly. Now at this point we can take the idea that slope equals rise over run and generalize it as follows. Here we have a formula for finding the slope of a line given any 2 points on that line. Let's use this formula to find the slope of the line we just examined. Now 2 points on that line were 1, 4 and 5, 3. So first we'll let coordinates 1 and 4 be equal to x-coordinate 1 and y-coordinate 1. And then we'll let coordinates 5, 3 be equal to x-coordinate 2 and y-coordinate 2. From here we'll take the slope formula and plug in the corresponding values. When we simplify this, we get 1 over negative 4, which we can also write as negative 1/4. Now it's important to note that it doesn't make any difference which point you select as the first point and the second point. For example, we can let the point 1, 4 be assigned to x-coordinate 2 and y-coordinate 2, and then we can let the point 5, 3 be assigned to x-coordinate 1 and y-coordinate 1. When we do this, the slope between the 2 points works out to be negative 1 over 4, which is still the same as negative 1/4. Okay, now let's examine some important features involving slope. As I mentioned earlier, some lines have a positive slope and others have a negative slope. This particular line has a positive slope. In general, if a line has a positive slope, then a point traveling from the left to the right on the line will move upwards. Here's what I mean. As this point travels along the line from left to right, it moves upwards. Now here's an example of a line with a negative slope. If a line has a negative slope, then a point traveling from left to right on the line will move down. Another important feature about slopes is that horizontal lines have slope 0 and vertical lines have slopes that are undefined. Now for the next important feature, notice that the slope of this line is 1/2, the slope here is 1, and this line has slope 3. Notice that as the slope increases, the line gets steeper. Now let's examine some lines with negative slopes. The slope of this line is negative 1/3, the slope here is negative 2, and this line has slope negative 5. Here the lines become steeper as the slope decreases in value. Now in general, we can say that as the magnitude of the slope increases, the line gets steeper. Okay, let's summarize. In this lesson, we learned 2 related approaches for determining slope. We learned that slopes can be positive and negative, and we learned that as the magnitude of a slope increases, the line gets steeper. In this lesson, we will examine x and y intercepts of lines. We will begin with x-intercepts. The x-intercept of a line is defined as the x-coordinate of the point where the line intersects the x-axis. So for example, this line crosses the x-axis right here at the point 3, 0. So the x-intercept of this line is 3. Now as an aside, please observe that the y-coordinate at the x-intercept is 0. We're going to apply this property shortly. Now y-intercepts are very similar to x-intercepts. The y-intercept of a line is the y-coordinate of the point where the line intersects the y-axis. So since this line crosses the y-axis at the point 0, negative 2, we say that the y-intercept of this line is negative 2. Now please observe that at the intersection point here, the x-coordinate is 0. We're now going to apply this property as we find the x and y-intercepts of the line defined by the equation 3x plus 4y equals 6. Let's find the y-intercept first. To do this, we will use the fact that when a line crosses the y-axis, the x-coordinate is 0 at the point of intersection. So if we let x equal 0, we can take the equation of the line and plug 0 in for x to find the corresponding value for y. When we solve this equation for y, we see that when x equals 0, y must equal 1.5. So one solution to this equation is x equals 0, y equals 1.5, which means the y-intercept here is 1.5. We'll now use a similar approach to find the x-intercept. Now we already know that when a line crosses the x-axis, the y-coordinate is 0 at the point of intersection. So if we let y equal 0, we can take the equation of our line and plug 0 in for y to find the corresponding value for x. When we solve this equation for x, we see that when y equals 0, x equals 2. So another solution to this equation is x equals 2 and y equals 0, which means the x-intercept of the line must be 2. Now if we take these solutions and plot them in the xy plane, we can see that the resulting line has x-intercept 2 and y-intercept 1.5. Okay, let's summarize. In this lesson, we learned the definition of x-intercept, and we learned that we can find the x-intercept of a line by plugging y equals 0 into the equation. We also learned the definition of y-intercept and how to find the y-intercept by plugging x equals 0 into the equation.